Awesome. So we'll shortly introduce ourselves, a little bit about us, the GTAs. My name is Ben Keene. I'm a graduate student at UCF. This is my second semester there. I'm working on a PhD in math. So as you can tell, I like math a lot. I really enjoy working with Dr. Kwan in the Math Circle. It's a great opportunity, and it's a great opportunity for y'all. I think Athanasios, you're next. You're muted, we can't hear you.
It is the double mute thing that I tell you. So I have another mute here. Okay, hi everyone. My name is Athanasios, and I have a very hard name, as I told to the guys yesterday who don't remember it. So I'm repeating it for them too. I come from Greece. I am a PhD student as well here. It's my second year already here. It's amazing. And I'm very excited to work with everybody. So yeah, I mean, there's nothing interesting about me, I guess, other than that. Okay, so Jess. Yes.
Hi, everyone. My name is Jess. I came into the program with Ben and actually with Gray. So this is our second semester in the PhD program, and I love it thus far. I'm still studying math. I've been studying math for a long time, so still kicking. I'm really happy that you guys have this opportunity. It's very cool. I definitely encourage you guys to stick with it. So I'm gonna hand it off to Gray. You can run with it.
Hi everyone, my name is Gray Carson, and I'm going to be doing the presentation today. So let me share my screen real quick. All right, can you all see that? Awesome. All right, so today we're going to be talking about modular operators, which is really cool, and it's used a lot in more advanced mathematics and computer science. So basically any sort of STEM field, any sort of science field, it's going to use computer science, so you're going to use these. So they're very important. All right, so we use these every day when we talk about time. So you already sort of know how to use them. So I put the example here. If it's 11 a.m., what time is it going to be in 5 hours? It's going to be 4 p.m. instead of 16 a.m., right? Because we have that cap, right? Because when we think about time and standard time, we have it through 1 through 12 o'clock. And so as soon as we hit 12 o'clock, we just sort of reset to 1. We don't keep counting up. And so that's what modular arithmetic is. It's hitting a cap and sort of restarting. The only difference is, with the actual problems we're going to do, is when we tell time, it's 1 through 12 instead of 0 through 11, like if we had a mod 12, because we don't ever hit the cap when we do that. But we're going to talk more about that later, so don't worry too much right now. So let's see. So the way we actually said it's the remainders. The mod is the remainder. So it's 4 is the remainder when we divide 16 by 12. So let's talk notation real quick, then we'll get right into some problems. Here's the notation. It's just not going to be
on the top. Where
nice.
is that? There is a
this thing. All right, we're just going to go with that. Let's see. All right. That works.
Yeah, do that. That's all right.
All right, sorry about that, everyone. All right, but let's get back into this. So the example we just did up there is we said that it wouldn't be 16 o'clock, right? It'd be 4 o'clock. So let's write that problem in terms of this notation. So we had 16 mod. Oh, it's gonna correct everything now. Let's see. 16 mod 12. That's going to equal 4. So that's how we write this in this notation. Because we had 16 is the number we're dividing by 12. Oh man. It's the number we're dividing by 12. And our remainder is 4. So 4 is our answer. Does that make sense to everyone? All right. So if that works, then we can get into some examples here. So let's do this first example, 7 mod 4. Does anyone want to help me out here? 3, perfect, thank you. Exactly, so does anyone want to explain how they got 3? You can use your mics if you want. Anyone?
Okay, so you would 4 goes into 7 one time, and that leaves over 3. the remainder is 3. So the answer to the problem would be 3.
Exactly. Perfect. Thank you. All right. So what about this next one, 15 mod 3? Let's see. Get to the chat here. 0. Perfect. Right? Because our remainder is 0. 3 divides perfectly into 15. All right. What about the third one here? 19 mod 4. 3. Perfect. And this last one? Let's see. Getting 1. Perfect. And you guys are fast. Look at this. All right, we have more exercises here. Does anyone want to all right, I'm already getting answers. So we've got 2 for the first one, perfect. All right, what about the next one? 0. What about this next one? 2, amazing. This one? 1. Oh my God, you guys are so fast. This is great. This next one? Also 1, perfect. What about this one? 4. Wow. All right. I'm impressed. We're gonna get into a harder problem now, which I'm really excited about. This is a word problem now, but it's gonna use the same sort of math. All right. So here's the word problem. Using a regular deck of 52 cards, I'll deal all the cards in the deck to 3 people, including myself. Were the cards dealt evenly? All right. So I'm seeing people saying no. So can someone get on the mic and explain to me why not?
52 divided by, sorry. Because there's a remainder left.
Perfect. There's a remainder, yeah. So how would we write this in terms of the mod?
So it says 3 people, including myself, so there's 4 people in total. So 52 mod 4 equals.
So it's actually 3 people, because it's
Oh, just
3
3.
including myself. Yeah,
Okay.
but that was a good point though. And I'm seeing it in the chat. We have 52 mod 3. Oh, that turned it into an arrow. Isn't that exciting? That equals 1, and so it's not even. Perfect. All right. Let's move on. So now we're gonna be working with some bigger numbers, and not only bigger numbers, but numbers that are so big that we're gonna add them together, make them even bigger. All right. So this is modular addition. So we're gonna look at 2 methods. All right. So we see this problem. We're gonna consider 1,824 plus 326 mod 2. Now, there's 2 ways to do this. I'm gonna shortly outline each of these methods, and then we're gonna do some problems and decide which method we want to use. All right. So we have method 1. We can just go ahead and add those 2 numbers together and then mod the big number that we just got. So we had the 1,824 plus 326. We're gonna add those together. We're gonna get 2,150, and then we're gonna mod that by 2. All right, so that's just adding them together first and then mod. But then there's a second method where we can sort of distribute that mod to each of those problems. So we have the 1,824 mod 2 and the 326 mod 2. We compute each of those, and then we add those together. And we get the same answer, which is a very cool thing. All right, so is anyone following? Anyone want me to go over either one of those again? All right. So let's get into some examples. All right. Okay. Does anyone want to do the first one here? Sure, Armin, go ahead. Do you want to get on the mic?
All right, so 7 plus 6 would equal 13, correct? And you can use 5 2 times because you can use 5 plus 5, which equals 10. So you can get that evenly, and the mod, the remainder would be 3.
Beautiful, thank you.
No problem.
So what about using the other method? Does anyone want to do that? No?
All right. I can do it. So for when you do, so you have to distribute, well, I would say, into using the mod 5. So what would you do is you would see how many times 5 goes into 7, which is 1, and what's left over from, well, I would say 7 minus 5 is 2.
Mhm.
And then when you go to 6, 5 goes into 6 one time, and what's left over from 5 minus 6 is 1. So when you add those two together, the overall modular is 3.
Perfect. Thank you. That was a perfect explanation. All right. What about the second one? Do you want to get on the mic?
Can I?
Yeah, go ahead.
I think for this, in this case, it'd be much easier to use the second method. So if you do 19 mod 5, you would get a remainder of 4. So you would do 4 plus 28 mod 5, which would give you a remainder of 3. So therefore, the answer would be 7.
Okay, so that's really good. But the thing is, we're not quite done because 7 is still bigger than 5. So we have that one last step in this thing. So we have to actually have 7 mod 5 as well.
7 mod 5 would equal 2.
Perfect, thank you. So yeah, so our answer is 2. Awesome. Okay, let's see. All right, got some more. Anyone else want to chime in?
So 5 mod 4 is 1 with a remainder of 1, and 9 mod 4 is has a remainder of 5, and 5 plus 1 equals 6, but 6 is more than 4, so it's 2. So R is 2.
Okay, so that's great. But so you said that we're going to distribute the mod 4 to both of the numbers, the 5 and the 9. And so you were right about the first one. 5 mod 4 is 1. But 9 mod 4. So 5 is good, but we're not quite done yet because we want to continue. We want to find the remainder, right? And so that's actually going to be 1 plus 2. Or sorry, 1 plus 1. Let's see. Delete that real quick. So we've got 1 and 1. Look at these arrows. That's a 1. So that equals 2. So you were right, you got the right answer. But there's a little step in there. Perfect. I see people in the chat. Awesome. All right. Anyone want to do the next one?
Okay, so I think the second method is easier for this one. So 43 mod 3, that would be 1. And 37 mod 3 would be 1 as well. So then you would do 1 plus 1, and that's 2.
Perfect. Thank you. That was very well done. All right, what about this third one? Anyone want to try this? I know the numbers.
Can I go again?
Let's see. Is there anyone else? And then if not, we'll go back to you.
All right.
Anyone else who hasn't talked yet? No? All right. So Armin, go ahead.
All right, so 124 with a mod of 5, you would have a remainder of 4 because 5 times what's it called? Some number that equals 120, but the remainder is 4. But I know automatically that 120 is a what do you call it? Product of 5. But besides that, and then 199. The remainder would also be 4 because 195 fits in with the mod of 5. So 4 plus 4 equals 8.
Perfect. So we have one more step though, right? because we
I
want
don't think so.
this 8 to be less than 5.
Oh, that would be 3 then. Yeah.
Exactly.
Yeah, 3.
Perfect. Thank you.
Because A minus 5 equals 3. Yeah, my bad.
You're good. No, you're good. That was perfect. Thank you. All right. Looks like is it Rayleigh wanted to do one of them? Is that correct?
Yes, Rael.
Rail, I'm sorry. Go ahead.
Okay, so I did 121 plus 34 equals 155.
Okay.
And then 155 divided by 11 has a remainder of 1.
That's a remainder of 11.
No, it's a remainder of 1.
Perfect. Yeah, so 155 mod 11, that equals 1. Perfect. Thank you. All right, so those were pretty awesome, right? So we can get into another word problem here. All right. So if my birthday was on Tuesday, March 5th, 2019, what day of the week will my birthday be on in 2020? Well, let's note that 2020 is a leap year. All right. Does anyone want to try this? So we can solve this using mods. Let's see. I'm seeing some answers in the chat, but can I get someone on the mic to try to explain the reasoning? So Brandon or Ryan, do you want to explain your thought process?
I just did it because the leap year is just one more day, so I would just do Tuesday is just one day behind Wednesday.
Okay, I see what you did. But there's actually another way to do that because oh, let's see someone in the chat. 366 mod 7. Do you want to get on the mic and explain that? No, okay, that's fine. But you're right though, because we have 366 days, and then we want to mod 7 because there's 7 days in a week. So the answer. So I mean, does anyone know what 366 mod 7 is? See 2. Yeah, it is 2. Does anyone want to explain how they got 2?
You mean like just division? What?
I mean, you could do division, but there's like, different methods to it too.
Oh, I'll just use how I got to the general number of 2 as a remainder from that whole number by using just the distribution. Well, not distribution. Because I used 7 times 50 to get 350. And that 350 minus 366 is 16. 16 divided by 7 is 2. And 16 minus 7 times 2 is 2. So the remainder of that whole, the mod of 366 is 2.
Perfect. That's exactly what I was looking for. Yeah, because we can, let's see, because when we used our modular addition, we can put them together, but we can also take numbers apart and use the same methods that we just used. So Wes was completely correct by breaking this 366 into 2 parts, the 350 and the 16, and then we got 2. So this equals 2. And so this means it's going to be 2 days after Tuesday. So we have Tuesday, Wednesday, Thursday. So my birthday would fall on a Thursday in 2020. Let's see, I did it by figuring out how many days were from the start of the year. Oh, that's interesting. I added 1 day. Did that work, Naomi? That's a really interesting. Did? Wow, I like that method. Very cool. All right, so how does everyone feel about that problem? Do we have to mod 2? Perfect. Liking the chat, liking everyone's answers. Very cool. All right, let's move on. All right, next, modular multiplication. Potential for making numbers even larger. All right, so here's
X mod and times X mod and
yeah, we're breaking this up into the if we have a multiplication, we have a x times y mod n. We can break this up into 2 parts, right? Just like how we did addition, we're gonna do the same thing with multiplication. We're gonna break it up and then take the mod of the whole thing. All right, I'm gonna let everyone finish writing that. Oh, no worries. Let's see. This is it's a nice little formula, right? All right, I see people writing intensely, so I'm gonna give you guys a minute. I like it. Would this be like the distributive property of multiplication? Distributive property of multiplication. Let's see. Do you want to explain what you mean by that? The distributive property of multiplication? Because it is very much like that. When we're taking the mod and we're giving it to x and y, and then we're taking the mod of, you know, the product of those 2 numbers. So let's take this formula and try some for ourselves. Should we do this like, you would do 7 times to get your answer. It's very similar, yeah, but yeah, because we are distributing that mod to each of the numbers. So I like that. Cool. All right, so does anyone want to try this first problem?
Me, I guess.
Yeah, go ahead.
So if we multiply, well, if we do, for example, 5 times 9, right?
5 times 9. Well, we can use our little formula here, and let's distribute that mod in to each of our numbers first.
Oh, okay. So what we would do is 8 does not go into 5 at all. So it would be, that would remain as 5. 8 goes into 9 1 time. And then the number left over from that is 1. So 5 times 1 is 5.
Perfect. Oh my God, this is not an ideal drawing system, but yes, I like your answer. Let's see, it was 1 that just disappeared, but yeah, so 5. Very cool. Are we multiplying the numbers then dividing it by the mod? Dividing it by the mod. Not necessarily dividing, but we are taking the mod of the product of the 2 mods. We're taking the mod 3 times really. Let's see, because up here we're taking the mod n of x and of y, and then we're going to multiply those answers together, and then we're going to take the mod n of that answer. Yeah, of course. All right, so does anyone want to try the second one?
Can I try this one?
Sure, yeah.
So 7, so first we would break it up into the formula that you just gave us, which would be bracket 7 mod 7 times 15 mod 7. And 7 mod 7 would equal to 0 because 7 goes into 7 1 time exactly. And 15 mod 7 would equal to 1 because 7 times 2 equals 14. And what remains is 1. And you can't do 1 mod 7, so the answer would be 1.
Let's see. Well, I like your thought process a lot. I think that's really good. But we have 7 mod 7, right? That's 0. And then we have this times 7 mod 15, which is 1. So you're correct on that. But then we have to multiply these two together. And so
That's
this is
right.
gonna
I forgot it was multiplication, so it would be 0.
perfect. Thank you. Yeah, because whenever we see this number, can you see my mouse here? Anyone? Okay. Yes, you can see my mouse. Cool. All right. So we have 7 here and a 7 here. So it's going to be 0 because this multiplication includes that number that we're in the mod. All right. What about this next one? Got some pretty big numbers here. Anyone want to try this? Let's see, I'm getting answers in the chat. Anyone want to get on the microphone? Sure.
So we do the formula. We do 5,782 mod 10, which would give us a remainder of 2
Perfect.
times 9 for the other number, and you get 18.
Get 18, yeah. So what happens with that 18?
You want to mod 10 to 18, right?
Exactly. So would that
And
be
you get 8.
perfect? Look at that. Very nice. Thank you. All right, what about this next one? Let's see, Wes is raising his hand. You want to go?
Okay, so 600 divided by 60 is 3. Well, so 60 divided by 600 is 600 divided by 60 is 10, and the number left over from that is 3. 120 divided by 60 is 2, and the number left over from that is also 3. So when you multiply those numbers together, you get 9. So the mod of the equation is 9.
Perfect. Thank you. All right, I see someone in the chat saying they want to do it next. Do you want to go ahead?
Hello.
Hi.
So 12 goes into 16 one time, and like the remainder is 4. And 12 goes into 25 2 times, and the remainder is 1. So 4 times 1 equals 4.
Perfect. Thank you. Very well done. All right, I want to do this last one.
Could I do it?
Yeah, go ahead.
Okay, so 34 mod 11 would be 1 because 11 times 2 is 33 and I have 1 left over. So that'd be 1. And then 122 mod 11 would be 1 as well because 11 times 11 is 121. So 1 times 1 is 1. So the mod of the equation is 1.
Perfect. Love it. Awesome. Okay. So look at all those problems we just did. Look at those big numbers. All right, let's get into a word problem again, because this is where the real fun is. All right, a liter of milk is 4 cups, and 1 cake recipe uses 3 cups. Let's see. Now my screen is blocked. If I have 8 liters of milk, how many cakes can I make, and how many cups of milk will be left over, if any? Let's see, I'm getting stuff in the chat. So I'm seeing 32 cups of milk in total. That's right, because let's see, we have what, 8 cups? And then we have, or 8 liters. That each one of that's 4 cups.
Oh.
Yeah. So let's see. anyone want to get on the mic and help me work this out? See, Brandon's raised his hand. Go ahead.
So I did 8 times 4 to find out how many cups of milk there are, and it's 32. And then you can do 3 times 10 to get 30, so there'll be 2 cups left over. Which
Perfect. So we have 2 cups left over. Okay. So that answers the second half of our problem. Anyone want to try to take a shot at the first part of the problem? How many cakes can I make?
So can I chime in?
Yeah, go ahead.
All right, so since we already know that it has 2 milks left over, so we can go back to the original problem. We can do 8 times 4, correct? We can have 32, and 32 divided by the 3 is 10 with some remainder, which is a 2.
Perfect. Yeah. So we can put that in terms of mod, right?
Yeah.
All right. So how would we do that?
So we would put 32 on the left side with a mod of the 3, and it will come out to a 10 evenly with the remainder of the 2.
Perfect. That's our leftover. Like you said, we have 10 in there, which is how many I can make. Perfect. All right, that wasn't too bad. It's a lot of words, but it wasn't too bad, right? I like that problem. All right. So now we're gonna get into some other stuff. Okay. So we're gonna talk about common bases, right? So base is like the mod that we just used. So like if we have base 2, we have like even and odd numbers and binary codes. It's gonna be on or off, 0 or 1, even or odd, right? We can use 4 as a base between like 2 consecutive leap years, 7 like days in a week. And then we just have, like 12 hours in a day, like we said before, 24 hours in a day. We have, different days of the month, days of a year. These are just different bases we can use that we have to keep in mind when we're solving these kinds of problems. And so before I get into something else, let's do one more word problem that kind of, do we write this? You don't really need to. This is something you can look up later because it's something that we're going to know most of this in our lives, right? But we're going to use one of these in this word problem. So let's go ahead and look at the base 4, and you can write this if you want. Years between 2 consecutive leap years. All right, so if any given year n is either n mod 400 equals 0, or n mod 4 equals 0, and n mod 100 is not equal 0, then it's a leap year. Otherwise, it's not. And so this is a pretty cool way of being able to calculate if any year is a leap year, just using modular operators and modular arithmetic. So let's go ahead and let's do our word problem that's going to use that. So was the year 1900 a leap year? Let's see, I'm seeing answers in the chat. Okay. Oh, we got some debate here now. Anyone want to answer over the mic?
So 19,000 mod 4 would give us a remainder of 0, which is why it is a leap year.
All right, so you're right about the 9,000 mod 4. That equals 0. That's perfect. We also have to do it mod 100 and 400. So we can like fully check. Okay, so I'm seeing someone in the chat who just said that divided by 400 gets a remainder. Do you want to explain that? Over the mic. All right, so we got a point in the chat. It's 9,000 mod 400. And that equals, some remainder. Does anyone know what that remainder is? 300. Perfect. So because that's not 0, then it's not a leap year. So the answer is no, it's not. All right. What about the next problem? What about 2000? Saying yes. Anyone want to explain why?
May I?
Sure.
All right, so according to this, 2000 goes evenly with 400, which would equal 5 evenly. So 400 times 5 is 2000, and we have 0 as a remainder. So yeah, that would be a leap year.
Perfect. So we have this mod 4 is 0, mod 100 0, mod 400 0. So yes, this is a leap year. Awesome. All right, now we're gonna do some of my favorite stuff. All right, binary numbers and codes. Binary numbers are pretty awesome because they're so useful and they're used in so many things. Like computers, it all runs on binary. It's all just zeros and ones in your computers. And computers, calculators, barcodes, CDs, DVDs, TV, like and Braille, anything. It's binary. And so this is gonna be so useful with anything in like computer science or anything with engineering or building anything like that. You're gonna be using binary codes and numbers. So, all right, let's see. The basics binary code is just using zeros and ones, which I might have already said. So this is gonna be in base 2, right? Because there's 2 options. In every space, there could either be a 1 or a 0. All right, so we should probably know how to convert stuff to and from binary. So let's see. Sorry, the chat is in the way of my reading. There are multiple ways to express the binary code. Decimal form, binary, right? So decimal form is what we write about when we write numbers. That's decimal form. And the ones and the zeros, that's binary. So for example, I have 1101. It's binary form, and that is 13 in decimal form, right? Like 1001 becomes 9 in decimal form, and we can convert it to and from. So I think it'd be pretty cool if we could convert this ourselves, right? So let's learn how to do that. First, let's do a quick review of some exponents. All right. So for exponents, my exponent tells me how many numbers I have of my base. So if I have like, you can see x to the first, I have 1x. If I have x to the 2, then I have 2 x's, right? X times x. X to the 5th, I have 5 x's all multiplied together. That's what exponents mean. It's just telling you how many of that number that you have. So let's quickly go through this little table and fill it out, and it's going to help us later. So does anyone want to get on the mic and help me fill out this table? Let's see, I'm getting stuff in the chat. Oh, I see Brandon wants to help out. Get on the mic.
2 0 equals 1. 2 is like 2 to the power of 0 equals 1. 2 to the power of 1 equals 2. 2 to the power of 2 equals 4. And 2 to the power of 3 equals 8.
Perfect.
2 to the power of 4 equals 16. 2 to the power of 5 equals 32. 2 to the power of 6 equals 64. And 2 to the power of 7 equals 128.
Perfect. I'll look at this line. Let's see. 228. Perfect. Look at that. So this doesn't look like a 16, but I swear that it is. Let's rewrite that real quick. Perfect. Now, take note of these, maybe write them down or just have them in your head because we're going to use these. All right. So now that we reviewed some exponents, let's talk about actually converting. So when we convert binary to decimal, we are going to rewrite our numbers. Step one is we write out our number, right? So if I have 1, 0, 0, 1, I'm going to write it, but I'm going to leave some space in the middle because we're going to be doing some other stuff with it. So this is just rewriting our number 1, 0, 0, 1. And then here's where it gets interesting. This is where we're going to use the exponents of 2. We're going to start, okay, binary kind of goes backwards when we're converting it because this last one, 1 times 2 to the 0, and then it's 0 times 2 to the first. Because you see, this exponent is increasing each time, but we're kind of reading it backwards. So 1 times 2 to the 0, 0 times 2 to the 1, 0 times 2 to the 2, and then 1 times 2 to the 3. All right, so that's step 2. So we're just going to multiply each number by 2, starting with an exponent of 0 on the very last 2, and increasing the exponent by 1 each time. Oh, I'm seeing stuff in the chat. Yes, you're getting ahead of it, but yes, I love it. All right, because that's step 3, right? Because we're going to add them all together. We're going to actually calculate this. We're going to take each of our, we're going to do each of these calculations and add them all together. We're going to get 9. So yeah, so our 1001 in binary form is equal to 9 in decimal form. All right, so how does everyone feel about that? Anyone want me to go over that again, or can we do some problems? Kinda? Yeah? My mic is messing up. Let's see. All right, how's my mic now? Okay. All right, I'm seeing people say they understand. So we're gonna do some examples. We're gonna solidify this stat. We go to step 2. Yes, we can. This is the, oh, okay, awesome. Yeah, because we're just multiplying each number by 2, starting with an exponent of 0. They're still static. People are saying they still understand the static. I have not changed anything about my mic. All right. All right, we have about 5 minutes. All right, so let's continue. Unplug and replug. Let's try that. All right, ready? No. It just kind of randomly happened? Yeah. Oh, perfect. Awesome. All right, let's move on. Yes, thank you everyone for helping me solve that crisis. All right. That's how you fix stuff. Exactly. All right. No. Okay, let's keep it moving though. All right. Does anyone want to try this first problem? Let's see. I'm seeing someone in the chat. Does anyone want to get on the microphone?
I will do it.
All right.
So if we break the number apart, 0 times 2 to the 0th power is 0. 1 times 2 to the first power is 2. And the other one in the hundredth place times 2 to the power of 2 is 4. So when you add 4, 2, and 0 together, you get 6.
Oh man, I can see that correction. I don't like that, but we're gonna deal with it. Wow. All right, it's 6. That weird little symbol is 6. All right. What about this next one? It got worse. I unplugged and replugged. Good. All right, let's just get through this. What about this next one? 101. Let's see, I'm seeing people in the chat. Does anyone want to get on the microphone? Anyone who hasn't spoken today? Anyone who has spoken today?
May I try the next one?
Sure, yeah, go ahead.
So 101 would be, well, you first break it up into spaces 101, and 1 in the ones place times 2 to the 0 power is 1. And 0 to the 0 times 2 to the first power is 0. And 1 times 2 to the second power is going to be 4. And if you add all those together, you will get 5.
Amazing. Look at that. How does everyone feel about that? Everyone good? How do we know what power we are using? That's a good question. All right, we're gonna go up here again, and we're gonna start with the power 0 in like on the very right side. We're gonna start with 0. Then we're gonna increase by the power by 1 each time we go. Right? So this first one on the very right, it's gonna be 2 to the 0, and then 2 to the 1, and then 2 to the 2, and 2 to the 3. Does that make sense? Okay, awesome. My mic magically fixed itself. I'm glad to hear that. It's the power of math, everyone. Okay. I'm not. All right. Anyone want to do this next one?
I can try.
Awesome.
Okay, so 1 times 2 to the 0 power is 1. So 1 times 1 is 1. And then 1 times 2 to the first power is 2. 1 times 2 to the second power is 4. 0 times 2 to the third power is 0. And then 0 times 2 to the fourth power will also be 4. I'm in 0. I'm in 0.
Yeah, I got you. All right. So now what do we do?
And then we add everything up and we get 7.
Amazing. Love it. Look at that. All right. I got a really good question in the chat. Let me scroll up to it. Erica and Kaya asked, is there any specific reason we use 2? That's a really good question. There is. It's because we have 2 numbers, right? We have 0 and 1. And so because we're using base 2 here, that's why we're using 2. So when we convert to and from binary, we're using that base 2. So we're going to be using 2 to some exponent. Awesome. That was a really good question. Thank you. Okay. Anyone want to do this last one? Ooh, I got it in the chat. Let's see. So we got 32. We got 0, 0, 0, and 0. And then we got 1, which is 33. Yes. I thought I read it as 38 for a second. I was concerned. That was just my eyesight. So we have 32. Let's see. Let's work backwards. So we have 1 times 2 to the 0. We have 0 times 2 to the first. 0 times 2 to the second. 0 times 2 to the third. This is 0 times 2 to the fourth. And then 1 times 2 to the fifth. So exactly. All right. Let's do a word problem. How many different, I love this problem. All right. How many different 5-digit binary numbers are there? Can you count? Wait, can you just count how many digits there are and then count forwards? Yeah, you can do that. It's a good question. All right. Anyone wants to try this word problem? It's intimidating, I know, but it's a fun problem, I swear. If anyone wants to try it. All right, I'll get it started, but I want you all to help me finish it, all right? So we're gonna have 5 spots, right? We're gonna have 1, 2, 3, 4, 5 in our 5-digit one. Every 5-digit binary number has to start with a 1. Let's see, with a 1. Because we don't have the option of a 1 or 0, because that's if it's 0 in the first place, then it's called a 4-digit number. That doesn't really, let's see. So now for the rest of them, we have either a 0 or a 1, right? So this could either be a 0 or it could be a 1. A 0 or a 1, a 0 or a 1, and a 0 or a 1, right? So we have 2 options for this, 2 options for this, 2 options for this, 2 options for this, but 1 option for this. So what would the answer be? How many combinations do we have?
Oh,
9? That's a good guess. Oh, but I'm seeing the correct answer in there by Ryan and Wes, Naomi. Yeah, it's going to be 16. Because we're going to multiply each of these choices together. Perfect. So what about how many of those ended in 1? Oh, yes. Seeing the right answer already. So for the second problem, it's an 8. Because it's the same problem here, except this 2 is a 1. Because we'd only have 1 option. Turn the 2 into a 1. Perfect, yeah. Because we have 1, 2, ooh, a 2, 2, 2. Then this 2 would be a 1 because we only have 1 option for that. So that's going to equal 8. Amazing. I love that problem, to be honest with you all. All right, we have our last topic of the day, converting decimal to binary. Let's see, how are you on time? We're going to compute our digit with like, okay. So we're going to take the number, we're going to, let me show you a visual because I just love this more. So check this out. So if I'm converting 13 to binary, I'm taking that 13 and that's equal to 2 times 6 plus 1 because it's 2 divided by 13. That doesn't go into it. So we're going to add the 1 here, but then it's going to be 2 times 6 plus 1 is 13. We're going to take that 6. We're going to do the same thing with the 6. That's 2 times 3 plus 0 because it's an even number. And then we're going to take the 3 down here, and it's 2 times 1 plus 1 is 3. And then finally, we're going to take that 1. That's 2 times 0 plus 1. So if it's an odd number, we're adding a 1. If it's an even number, we're adding 0. And then we're just dividing it by 2 each time and taking that number that we have to divide. And then we're bringing that down. So how does everyone feel about this? All right, so I'm getting that we want to maybe continue next time. Dr. Kwan?
Yeah, I think if you have application problem and so on, then probably it is better to continue next time.